Hi everyone, our next type that we're going to tackle are radical equations with a variable appearing more than once. So really just like with all of these, we're a little limited with quadratics or rationals or radicals in that we need to not end up with more than one power of our variable. But that leaves us with a lot that we can tackle. Okay, so this first one, what I'm seeing is you could square to get rid of the square root right now, but you would have to do some foiling. So let's see. I think if this is a thought you're having, it's not a bad one. Remember, we're supposed to free our variable first. But here, if you do that, you'll have to FOIL out 2 root k minus 4 times 2 root k minus 4. And you're going to get, 4 times k, and then outside is minus 8 root k, inside is another minus 8 root k, and last is plus 16. So we did get rid of the root on the 1k, but we still have roots on the other side. Actually, I might just venture through this. I'll show you an alternative way, but looking at this now, I actually think it might work out to be solvable for us now. If not, I'll tell you when I hit that. Okay, so now I can say, combine some like terms. Negative 8 root k minus 8 root k is negative 16 root k's. Okay, so I'm not loving that I still have a root in there. So generally my strategy would be, and you will see equations where you have to do this, if you want to get rid of a root, you need to isolate it and then use the power. So I need to work on isolating that root. So I'm going to go ahead and subtract 4k and also subtract 16 from both sides. Okay, so I have negative 16 root k left on this side, and I have negative 3k minus 16. Oh, I am going to get stuck. Okay, so let me just show you so that you can see it as well. Let's divide everything by negative 16, so the k really is by itself. And you could do some simplifying there, but what I'm seeing is that to get rid of the other radical, you'll have to square both sides. And it's not that that's so terrible, but when I square that, I'm going to get a k squared and a k, and I'm going to get in trouble because it's going to turn into a quadratic. So this isn't, it's impossible. This is, we don't quite have the tools yet. So let me take you back to the beginning after that long sidetrack and say, whoops. Hope I didn't make you motion sick. I was looking at 2 root k minus 4 equals root k. And what I was spotting before I went down that rabbit hole was that I do have k's on both sides. They're both stuck in roots. Those are like terms. So I could move my k's. I'll go ahead and move them right this time by subtracting root 2k from both sides. So I have a negative 4 left on the left-hand side. On the right, I had 1 root k. I subtracted 2 root k's. I'm left with negative 1 root k. That's a lot better than that mess that I was building up in the last problem. So not to say that we'll never have to do what I was doing in the last problem, but we don't have to do it here, so let's not. Okay, so now that I'm down to 1k on one side, I look at my operations. The k gets square rooted and then multiplied by negative 1. So the first thing I'm going to do is divide out that negative 1. And I have to do it to both sides, so I get positive 4 equals root k. I then have to square both sides to get rid of the square root. So I get k equals 16. And you do need to do kind of a careful check on these because the problem here is when you square both sides, that's like multiplying both sides by a variable and it can introduce an extra solution. But it's a little more subtle when you go back and plug in. You're looking for a plus minus problem where you wish something was subtraction instead of addition or vice versa. So I have, for my check, 2 root 16 minus 4, and I want to know if that equals the square root of 16. So the square root of 16 is 4. Does 2 times, oops, I'm thinking ahead of myself, 4 minus 4 equal 4? And I would say yes, 8 minus 4 does in fact equal 4. So I think 16 is a good solution. So we still have to be a little clever and try not to build up quadratic equations that we aren't yet able to solve. Sometimes that just means moving things around a little before you start trying to get rid of your square roots or fractions or whatever it is. Okay, let's see what else I created here. I'm going back to blue. I like blue better. Okay, so this one I have them on both sides. I have them stuck in square roots. There's not really a lot I can do to rearrange. I don't want the roots on one side. I want to isolate a root if I'm going to try and get rid of them. So if you remember way back at the beginning of this section, I had tips on how to get rid of certain things. If you're trying to get rid of, if you're trying to free a variable from a root, you want to isolate the root and then get rid of it with power. So I already have the root 2u plus 4 isolated. I'm going to go ahead and just square. I want you to be really, really clear on the fact that when I do that, I'm squaring the entire thing. So the left, that's not anything that I think would have given anyone trouble. I get just 2u plus 4 because the root and the power cancel. On the right, what you have to be careful with is really what you're doing here is multiplying 3 root 2 minus 3u by itself. So you're going to get a 9 out in front, right? So you have to square the 3 as well. And then when you multiply root 2 minus 3u by itself, you get 2 minus 3u, no root left over. Okay, so I wiped out both roots in one step. That's fantastic. What I'm seeing now is that on the right-hand side, my variable is stuck in parentheses. So I'm going to go ahead and distribute. I'm going to say 9 times 2 is 18, and 9 times 3 is 27. Okay, oh, I guess I don't really need to move up. Really good, my variable's not stuck anywhere anymore. I'm going to go ahead and move all the u's to the left-hand side. And I get 29 u plus 4 equals 18. So now reverse order of operations. I multiply by 29 and add 4. So to reverse it, I will subtract 4. And I get 29u equals 14. And then I divide by 29. And I get u equals 14 over 29. And I really don't want to check it, but I probably should. Let me think about it. So I'm going to get, check, square root of, okay, so I'm doing 2 times 14 over 29, which gives me 28 over 29. 2 times 14 is 28. And then I need to add 4, which I can work on in a minute. And I want to know, does that equal 3 times the square root of 2 minus 3 times 14 over 29? What is 3 times 14? 28, 38, 42 over 29. Okay, so what I'm thinking, oh, this one's so ugly to check. Okay, so we'll multiply top and bottom by 29. So 4 times 29 is, what, 80 plus 36, 116. And then if we add 28, I wish I had anything but my phone to double check my arithmetic right now. 116 plus 28, 116, 126, 136, 144. Oh, well, that at least is a good sign. I see root 144 over 29. 29, not looking real pretty. 144 is a perfect square. Okay, so this one, if I multiply 2 over 1 by 29 over 29, 2 times 29 is 58. So 58 minus 42 is 16. That one's looking promising as well. root 16 over 29. Feel free to use a calculator on these checks for exams or whatever. I'll try to be nice to you about the numbers on quizzes. So you could rationalize denominators, but what I'm seeing is if I split that root up, the square root of 144 is 12. The square root of 16 is 4. And if I multiply on the right-hand side, 3 times 4 is 12. That looks great. I don't have any sign problems. So I think I like it. Okay, I think I only did the 2 for radical here. We'll do more in the next section, but that should give you some practice for this section. Thanks for watching.